Here's a video clip from an actual cardboard boat race. Here you see the blue surf boat design. That was our team's. The red team wore a conventional surf boat, starting to buckle in the middle. Here we've taken the lead on the first lap. We went on to win all three races, and we were unsinkable and unbeatable. And that's what the magic of math allowed our team to do. Come up with a clever solution to a fun design challenge. In fact, a couple of the guys actually managed to stand up on the surf boat. Well, for a few seconds anyway. Sound like fun? Well, today I'm going to show you how to think like an engineer and solve problems. Hi, I'm Dr. Marcia Tuft, and today I'm going to share my process for how to think like an engineer and learn to solve problems. And we're going to use what we learned to solve the problem of why do some things float and others don't. Interested? Let's go. First, tell me a little bit about yourself. What are your dreams? Do you want to invent or create something new? Perhaps you want to help people live better lives. Or maybe your goals are more along the athletic endeavors, like winning a gold medal at the Olympics or participating in professional sports. Whatever your goals, it takes hard work to accomplish big things. And what you do today matters. Learning to solve problems can help you achieve your goals, no matter what they are. I'd like to share a little bit about myself. My passion is helping students survive and thrive in STEM fields: science, technology, engineering, and math. My experience includes 35 years engineering experience at GE Aviation in Cincinnati, Ohio. My degrees include a bachelor's in mechanical engineering from Purdue University, a master's in aerospace engineering from the University of Cincinnati, and a PhD in materials engineering from the University of Dayton. But my road forward was not always an easy path. In fact, sophomore year at Purdue University, I got my first D ever in physics, electricity, and magnetism. I'd never gotten a D before in my life. C's were rare. And when I got that D, it rocked my world. Suddenly, I didn't know if I had what it took to succeed in engineering. When the rubber hit the road, it wasn't the awards that my high school physics project won that helped me to stay the course. That was just one project, part of a year. When I dug down deep, the bedrock on which I made my decision was all the creative projects I did as a kid in elementary school and later in junior high and high school. Things that I dreamed up, problem solved, and figured out on my own that helped me to stay the course. I knew that I was creative. I figured I just had to learn a new medium. So what you do today matters. And what I want you to learn is how to solve problems, because that's what I was learning with all of my hobbies, including sewing, painting, designing furniture with my dad, all kinds of stuff, drawing floor plans. Everything helped. So today, I want to ask, how would you design a surf boat? We're going to learn a problem-solving process that will help us predict whether something will float or sink in water and allow us to design a boat that will float. Sound good? Okay, first, I want to teach you a simple process for learning problem-solving skills. Now, this is hard work, and you're not going to get it in just one project. So my number one goal for you is to have fun and learn something. And the process will get easier the more you do it, as you build confidence that you can do it. Now, the challenge with teaching problem-solving skills is the student has to take the initiative. You present a problem or a situation, and then the student has to make a choice or take an action. As a result of that choice, you're going to get some feedback. You're going to have an outcome. And either you're going to be a little bit closer to your end goal, or you're going to figure out, oh, that didn't work. I'm going to have to try something else. I'm going to have to pivot. So it's learning by doing, learning from failure and learning from successes. Now, key to keep engaging in this process is to monitor your motivation. What's in it for you? Why are you going to solve this problem? So when you start with hobbies, the motivation is built in. That makes it easier. The other thing you need to do is kind of monitor your progress. So you're going to have small wins at first, and you need to celebrate those. Even sometimes the bad decisions where you figure out that's what the problem isn't, celebrate that too, because you've learned something. That's not the approach you want to take. It'll help you take the next one. So taking time to learn this, celebrate those incremental steps and keep it fun. That'll help you stay motivated to keep learning. And the bottom line is problem solving really is learning how to learn. And whatever field you end up in, you're never going to get all the knowledge that you need at school. You're still going to have to learn more on the job. And the problem solving process will help you figure out what you know, what you don't know, and what additional information you need to solve the problem at hand. This is a short video of my dog Harry doing some of his dog tricks. And this process is one that professional trainers at SeaWorld use to teach dolphins and killer whales the amazing routines and performances that they put on. Top dog trainers around the world use this process to teach their dogs cool tricks and to perform at agility trials and obedience trials. In a minute here, you're going to see my dog Harry weaving backwards through my legs, doing backward figure eights. And this was not an easy trick to train. We had to start off with Harry had to learn to put his rear legs on an upturned food dish. And then I would reward that. And then eventually he'd make a motion with his front feet. So relative motion from his front feet relative to his back feet. And I would reward that. So it's built up in small steps until he figured out to do full pivots around the food dish with his rear end pivoting on the dish and his front legs moving around. And see here, you can see some of the other tricks. It's handstands and two on the side and catching frisbees. These were all built up in small steps. When you start small, celebrate positive progress, you can do amazing things. But you have to start small and figure out how to solve that problem. Just like if you're training and lifting weights, you don't start off bench pressing 300 pounds. You start off with lower weights and increase the difficulty gradually. And that's what we want to do with the problem solving process. We want to start small, celebrate positive progress, and keep the learning cycle going and tackle one problem at a time. It can be a lot of fun if you do it right. And remember, wrong is wonderful because you're learning what the problem is and what the problem isn't. And that's what keeps our dogs, Harry here, motivated and willing to work, even when it gets tough. And that lets him adapt to new situations because he knows he can solve problems. So today, the problem we're trying to solve is why do some things float and others don't? So engineers learn how the world works, and this lets us design new things. Now, we use models, so we can use models like this wood boat here. But the most powerful models to refine our designs are math models. Because if we can model the behavior of how this floats using a simple math equation, now I can refine my design and do hundreds of calculations or thousands of calculations and optimize my design doesn't cost anything but a little bit of my time and some computer power. So that's the power of math. But first, we have to understand how the world works. So let's take a look at the slide. Okay, we've got a cruise ship that weighs tons. How does that float? And the submarine, that's able to sink or surface on command. It can control its buoyancy. Do you know what buoyancy means? It's just a term for how something floats in this case, water. Some ships float initially and then they sink. So, how can we predict this? Well, I'm going to propose 3 hypotheses. 1, is it weight? 2, is it size or volume? And 3, is it density, which is weight divided by volume? And does material matter? Does something have to be waterproof? What does that mean? So, and then what can we do if we can predict whether something will sink or float? Well, if we can predict it, then we can design and we can refine our designs. Sound good? Let's keep going. Okay, we're going to test 3 hypotheses. Do you know what a hypothesis is? It's a guess. And engineers propose a hypothesis about how things work, and then we design experiments to test it. Did you know that it's easier to disprove a hypothesis than it is to prove it? Because it only takes 1 failed experiment to disprove a hypothesis. But 1 successful experiment doesn't prove it because you haven't tested all the possible combinations and conditions. Okay? But if you test enough, you might have confidence that, well, this is how the world works under this range of conditions. So maybe I'm on the right track. Okay, are you with me? Let's go. Hypothesis number 1 is weight. So can you think of a simple test that we could do to prove or disprove whether something will sink or float? And that weight is a predictor of whether something will sink or float.